This question tells us that the following triangles are similar, which, as we learned recently, are the same shape but a different size. And it asks us to find the length of sides W and Z. W and Z are on different triangles here. The thing that's really different about this question than the previous one that we looked at here is that the second triangle, the larger one, the one that's colored red here, is turned upside down. And you will find this kind of a question on your benchmark for the end of semester 1, as well as on your the CST test that you take in the spring, because test makers want to be able to confuse you a little bit by just turning the triangle upside down. The strategy that we talked about in class, which is a helpful strategy to use, is simply to take and to turn it right way up again. So it is shaped the same way and positioned the same way as the smaller triangle. Then we can fill in the different numbers, and it's easier to be able to compare. Now we're basically looking at the same kind of problem that we did in the previous problem in this sequence that we solved. The thing that we need to do is we need to find two of the sides that match up, for example, the height on each of the triangles, and see if we can find two numbers to compare to find out what the ratio of these two different shapes is, how much bigger one shape is than the other. Here with the height, we don't have those two numbers. We have 4, a height of 4 feet for the smaller triangle, and a height of W, unknown, so that doesn't help us. Now if we look at the hypotenuse, which is the name for the long side in these triangles opposite the right angle, we can see on the right side for the larger triangle, we have a length of 10 feet, but we have an unknown number of feet for the smaller triangle, so that doesn't help us either. So we need to look here once again at the base. And in the smaller triangle, it's a length of 3 feet. In the larger triangle, it's a length of 6 feet. So now we have the information that we need to be able to solve this problem and to be able to find out what the ratio is. We can see that the ratio of the two triangles is 3 to 6. Or if we simplify that, it's 1 to 2. That means that if we're looking at the smaller triangle, we can take and multiply any side in the smaller triangle by 2, and we will have the length of the side on the larger triangle. So for example, if we want to find W, an unknown side on the larger triangle, we can look at the side that goes with that on the smaller triangle, which is 4 feet. And we multiply that times 2. 4 times 2 is going to equal W. So W is going to be 8. That's the solution for 8. Pretty easy once we found the ratio. So W is 8. And now we need to do something a little bit different over here to find Z, because that's something on the smaller triangle. So again, the ratio is 1 to 2, but here we're going to be dividing a side on the larger triangle to give us a side on the smaller triangle. Again, it's the same ratio, 1 to 2. In one direction we're multiplying, in the other direction we're dividing. So we have the side 10 feet for the hypotenuse. Again, that fancy name for the long side opposite a right angle. So 10 feet is the length of hypotenuse on the larger triangle. We take that. To find Z, we take the larger length, 10 feet, divided by 2. 10 divided by 2 is 5. So 5 feet. Z is the length of 5 feet for the hypotenuse of the smaller triangle. So there we found W and Z. The things that we've learned from this particular question is that if you have a triangle, two different triangles, two different shapes actually, that are positioned differently, one good strategy is just to take, and you can draw this on your test booklet, just to take and turn it around so you can see more clearly which sides you're comparing. And then find two sides that you can compare that both have numbers that you can match up. And find out what the ratio is for the two triangles. You can simplify that then and either multiply or divide to find the length of sides that are unknown, that are missing. Go ahead once you practice this and practice the problem that goes with this for the homework quiz for this week.